Hello, welcome to my new video, and today we will discuss the force-frequency relationship. So what is it? Well, force-frequency relationship refers to the relationship between the heart rate and the force of contraction. And what we now know is that as you increase heart rate, in other words, increase the number of heartbeats, you increase that force of contraction. And Henry Bowditch was the first person to have actually really published on this. And here's actually some of the original recordings. So you can see a transient, this is a contraction of the heart, and you can see the rate at which it's beating, which it is beating. So this is at 30 beats per minute, 0.5 hertz. And you can also see the amplitude of that signal referring to the size of the contraction. And as you increase the rate, so going from 30 beats per minute to 90 beats per minute, you also increase that amplitude, in other words, the force of that contraction. And as you then go back to 30 beats per minute, that contraction decreases as well. And we know this because, for example, when we get very stressed or scared, we know that our heart rate increases, but also we feel that heart pounding against our rib cage because that force of contraction is increased as well. The same is the case when we also do exercise, of course. So Henry Bowditch referred to this as a Treppe, which means in German step, so staircase. And the reason why I actually use German words, even though he was an American physiologist, is because he did this work in Leipzig together with some very famous German physiologist, Carl Ludwig. And this paper was published initially in German, and you can still see it referred to in textbooks as the Treppe, the staircase effect of the heart force-frequency relationship. So here's actually, we have the data now here in on a graph. So you can see there's a force of contraction on the y-axis, the heart rate or the frequency on the x-axis. Now in a non-failing heart, so in a healthy myocardium, as you increase the heart rate, you increase the force of contraction, obviously up to a point. But in a failing heart, and we will discuss the heart failure in a lot of our subsequent videos, you can see the opposite is true. As you increase the heart rate, you actually decrease the force of contraction. This has serious implications on the physiology and distribution of oxygen in these patients, and we will discuss that in some of our subsequent